Okay, we're continuing our discussion of the calculus of parametric curves. And so what we're going to do now is we're going to find the length of a curve. Now, in the past, we've looked at arc lengths of curves. And now we're going to take a look at basically the same thing, but in this case, we're going to deal with parametric curves. So it's really not terribly different. All right, we've got a formula here. The length of the curve CL is given by this integral from a to b, and it is the square root of f prime of t squared plus g prime of t squared dt, where f of t is your x parametric. So let's write that down. X equals f of t, and y would equal g of t. All right, just for the record. So let's take a look at an example, and this one's really quick. It says x equal cosine 2t, y equal the sine of 2t, and we're looking at this from the interval of t from 0 to 2 pi. So let's take a look. Let's see what x prime is. Well, x prime, derivative of cosine, is negative the sine, and then again, this is a chain rule problem. So you're going to say negative 2 sine of 2t, and then when you take a look at y prime, you're going to get 2 times this derivative of sine is cosine of 2t times 2, I should say. So 2 cosine of 2t. All right, so those right there are your derivatives. You plug them in. This one actually works out to be really nice, all right, because I'm already seeing what's going to happen. All right, 0 to 2 pi. I know I'm going to square it. I've got a sine. It's really nice. I'm seeing Pythagorean identities left and right here. So we're going to have right here a negative 2 sine of 2t squared plus a 2 cosine of 2t squared dt. All right, so what does that look like? Well, it's the integral from 0 to 2 pi of 4 sine squared of 2t plus 4 cosine squared of 2t dt. All right, that's what it looks like. Okay, so what I'm going to do is I'm going to factor out that 4. So again, I'm going from 0 to 2 pi. I factor out the 4, and that's going to leave me with a sine squared of 2t plus a cosine squared of 2t. Let me clean that up. All right. And then, of course, we've got our dt on the outside. But I see a Pythagorean identity, sine squared of 2t plus cosine squared of 2t. It really doesn't matter that the 2t is there because it's still 1. And this right here is going to leave me with an integral of 0 to 2 pi. We're left with the square root of 4, a constant, which is just 2 dt. All right, that's really easy to integrate now because it's just 2t, right? And it's a definite integral, so we're going to evaluate it from 0 to 2 pi. All right, and this is pretty straightforward because it's just going to be 2 times 2 pi minus 0. So what are we left with? We're left with 4 pi units. And let me clean up my pi there. It looks a little funny. But 4 pi units because it's length, so it's one-dimensional. So this right here represents the length of the curve. All right, the length of the curve is 4 pi units long, and it's really nothing difficult and really nothing to worry about. All right, so really nice how these parametrics have worked out, you know, and you can find the length of the curve. So as always, I hope this video was helpful, and remember, like and subscribe.